Okay, we'll go ahead and officially get started. So we can go ahead. Rachel, if you want to start recording for us.
It is recording now.
Thank you so much. So welcome. We know that you're so busy, so we are very thrilled that you are spending some time with us this afternoon. We will be careful with the time. So now about 57 minutes. We have a wide variety of people that have expertise around technology, around teaching. So because our webinar participants, like the numbers very small, please feel free to jump in and we can make this more of a discussion or a conversation rather than Rachel and I talking at you. The idea behind this is not to show you all the wonderful things and the amazing things that you can do in CODAP. It's to introduce some basics around CODAP. So we are representing Rachel and I, the Esteem team. Tim has been a very good partner of our Esteem team. And there's others of you here too who have been good partners. So it's good to see other people here. So thank you for supporting Esteem. But we just want to recognize this is a very large project. We have a PI at Eastern Michigan, Stephanie Casey, a PI at the University of Southern Indiana, Rick Hudson. Bill is a co-PI on this grant. So the Concord Consortium is a partner. I'm a co-PI. Holly Lynn is the PI here at NC State. And Rachel is one of our graduate research assistants. And then Emily and Adrian have been very important people and part of doing our work. And we wanted to thank NSF for their support of our work. So if you missed the bit.ly, we'll put the bit.ly in the chat again. This is a bit.ly. We don't have tons of slides for you, but it is a bit.ly to a PDF of our slides so that if you don't get all the links during the webinar, you could go back and have those saved. Also, it might be helpful for you to click on the links in the slide. So I'll just wait about another 10 or 15 seconds and we'll let people pull those up if they want. So the tool we're going to be using today is CODAP. I think that many of us that are participating in this webinar can talk about the many reasons why CODAP is a very good tool for learners at different stages in their understanding of statistics and data science, why it's a great tool for teachers or those that are preparing to be teachers to learn how to help students build their statistical and data reasoning and their reasoning about data science. One of the things for me in my own career path, I grew up on Fathom and Tinkerplots and I don't mean Sketchpad, you know, in terms of geometry, all of those types of wonderful software. And then I came to a point where I really wanted to rely on tools that were free or web-based. And so one of the reasons that I just made the decision that CODAP was going to become my tool in many instances was that you don't need a login. It's very easy. That's relative, of course, though, but it really is very easy whether you're a new learner, whether you're a learner that's used other tools to pick up and use. It's very friendly in terms of figuring out what the features are and trying to or making use of them to make sense of data. And it is web-based and free. So just some things from Bill in terms of some just background on CODAP. It really is designed to be a learning environment. So they take very seriously those that develop CODAP to focus on what we know about how people learn statistics and data science, about principles of technology, but then combining this as a tool so that you can do analysis and use visual representations, but that those things are aligned where the technology supports how we learn. So again, it's free, it's an open resource, it's web-based, it's very classroom friendly, whether you're working with students in upper elementary, middle school, or learners that are at a later stage in life. Again, it's based on research that started in the 1990s and the research that's continuing to go on now. And one of the ways CODAP has been built by Bill and those at Concord that work with him is that he partners with people to get external funding to build out the platform. And so, as of right now, there's more than 870,000 active users. It's in 16 languages. People in more than 50 countries are using it. And it can be a great vehicle for introducing data sciences across the curriculum. Yes, it's great for statistics and probability too, but now we're having more of a foci or the foci around data science is spreading. So that's just an introduction. And so for any of you that know me, you know that like technology is very important, but I can't talk about the technology without being in the context of thinking about data. So we are going to look at a data set to explore some of the basic features in CODAP. And so I'm going to share with you later a very large data set from a different project I work on called InStep. And that is a data set. What we did was, and I say we in the Royal Collective because I directed people that actually did the work. We found all the existing roller coasters. I think it was around the spring in the early 2000s. All the roller coasters that were in existence in the United States that were being that were in operation. And so we created a data set that will have more variables than the data set you're getting ready to look at. So if you have learners or if you're preparing teachers that are preparing learners who are ready to work with larger data sets, that might be your data set. The word of caution I have is that the data is different. So if you work in this data set where we're going to look at 157 roller coasters, you will really want to be careful to know that relationships that you see with the 157, they might not be the same as what you'd see with all the operating coasters. So that's just a word of advice and just like a little preview of something we'll share in a bit. So before we get engaged with the data set, we're going to watch two short clips. One clip is of a roller coaster called the Jackrabbit, and this is in Kennywood, Pennsylvania. And then we're also going to watch a video of a roller coaster called the King to Ka. And those roller coasters that roller coaster is a more modern coaster. So let's take a look first at the Jackrabbit.
So I'm writing an essay on cats in art history. I'm an art history major, and this final is due on Friday.
Okay, so I am going to now have us look at, and I think I already have this one open, so hopefully we don't watch the ad. I apologize that you had to watch that. Now the King to Come video is going to go very fast. I think this is only a like 28-second clip. So we're going to start this one. And I think that I did this so you don't have to watch the ad. Okay, that one went quick. So, what I'd like for us to think about before we move on to actually opening the data up is in the chat. Would you share some things you noticed about the different coasters and some things you might wonder about the different coasters that you saw? And if you want to feel free to compare those experiences of the different coasters, you could also share that in the chat. So questions like, well, how high did they go? What about these number of loops? Oh, you guys are great. What about the number of twists? That people are noticing they have different heights. I think they're all scary, Tim. Right. We're wondering about speed. And then someone's already pointing out that maybe the first one, the Jackrabbit, was a wooden coaster, and maybe the other coaster, well, clearly the other one had a lot of more steel parts, right? So even if students or your learners have not had experiences riding roller coasters, sometimes showing just a quick video can help us think about what are some things we might be interested in the data, right? Or what are some things we might wonder about? So if you open up this data set, so it says open data for 157 coasters in CODAP. If you click on that, you should open up a CODAP document. I think it's really interesting people's versions of what's fun because my daughter is a thrill seeker and she would love the King to Caw. I am a person that doesn't get a lot of excitement about going very fast. Well, no, it's not the going very fast. It's not having the control. So I love all of these things that you're already wondering or you have questions about. So when you open up this file, the way that it's designed is it opens up with a graph and it opens up with a table. So in a moment, I might show you how to change this to looking at case cards. But right now, we're gonna just take a look at the table. So the way that this file opens is in a hierarchy. And so we have these age groups that we created of coasters showing older, recent, and newest. And this is all relative because we picked what these definitions would be. So if you want to make this table just a little bit bigger, which I'm going to do at first, you can see that you have different attributes. So some of the attributes we have is we know the name of the coaster. If you would like to make that column larger, you can get in between these columns and you can pull it out if you want to make it larger or smaller to see the name. So if you hover over the attribute name, we can see the definition of the attribute. So we've set this file up that way. You notice that if you hover over any of the attributes, you get to see the name. So we know the name, we know the location, the city, the type of coaster, the design of the coaster, the year it was open. We know the top speed, the maximum height, the drop, the length, the duration, if it has inversions and how many. And then the latitude and longitude are here because we have a map feature that we'll take a look at in a moment. But what we've done is we've created something called a hierarchy. And so if I click on this hierarchy, if I click on older, so age group is an attribute, it puts all of the coasters that are the older together. It puts all of the recent coasters together. And sometimes this is a very helpful way to look at data. We'll talk about that a little bit later. one of the things that I do want to show you is that when it opened up with a graph, that it puts the coasters or the cases in here randomly. So there's no structure right now to the way the cases appear on the graph. Again, if you click on older, you can see that all of this is dynamically linked. So whether you have multiple windows open that are graphs, whether you have the case table open, whether you have the map open, and we can open that up too, all of those cases, you'll be able to find the case within each of the representations. So before we put some order to a graph, let's look at the map. So notice that the map is also linked. So you can see that of these 157 coasters, where these coasters are located. So if I were just going to pick a coaster, you will notice that the Anaconda is here in Virginia, it looks like, and this is where we see the Anaconda here, and then we also see it in the table. So let's look at some of the other features of CODAP. And so let's look at some of the graphical features. And one of the things that came up was speed. And so why don't we think about speed for a minute? And if we look at the attributes that we do have the top speed of the coaster. So if we go over to the case table and we find top speed, notice that, and now that I'm hovering over it, there's a little hand. I can drag that to where it says click here or drag attribute. So you could click on it. I'm dragging it to the axis, to our horizontal axis. And so now we have all the coasters and we have all their top speeds and they're arranged as a dot plot. So one of the things that students or teachers might be curious about is, well, where's the center, right? So if we were to talk about all the coasters and we wanted to talk about what an average or a typical speed is, where would that be? So one of the tools that I really love for working with younger learners or teachers who are going to teach younger learners is having students make some kind of estimate about where maybe those centers might be. And so sometimes students don't always give you one of the measures of center. They might think of some interval. So if anyone wants to put in the chat where they think the center might be, whether you can put in a value or you can put in an interval, I'm going to show you how you can add something called a movable line for students when they're making this guess of what this clump is to show where this is. So if you go over to your graph, there's different menus here. The eyeball allows you to hide things, to select things. It's very helpful from that aspect. If you're clicking on this ruler measure, it's going to give you things like counts. We're going to come back to this in a moment to measure different things. You can, even if you want, use the paint tool to change the color and the size, the backgrounds. We're not going to do any of that today. And then this graph feature, it's going to know which graphs are appropriate for whatever data you have. And so it's going to allow you some more options. But we're going to go back here, and I'm going to put in something called a movable value. And so I'm going to plot this movable value, and then I'm going to plot another one. And so what I was suggesting earlier is this can be really helpful if students haven't really narrowed down where that measure of center is, and they're just kind of thinking about what does this distribution say. So this is an example of how you can have students make guesses about where they think that center is. And then if we really want to know where the center is, we can go back to this measure tool and we can find the mean and the median. Notice that when I hover over the measure, it tells me what that measure is. So our mean, the typical top speed, of these coasters is 58.6 miles per hour. And then the median is 56.5 miles per hour. So I was like really off here with my clump of where that center might be. I kind of found the right area, but there may be a reason why these lie where they do. So when I move the cursor away, do you notice how now I don't see the mean and the median in terms of what the numerical value is? CODAP has a feature though where if you click on this measuring tool, you can click on show measure labels. And so now what it does is it'll leave those up there, and you see that I'm moving them around with my cursor. So that's very helpful sometimes for students. If you want to get rid of these movable lines, you have to go back to the measure tool and remove them one by one. So now we can see that we have this data set. We have our measures of center. We can see the dot plot, so we can see different aspects of the distribution, right? We can also use some other graphical measures that might be helpful if we're talking about typical speed. For example, if we want to think about a measure of spread, well, we could graph that. I think we could do a box plot. So one of the great features about the box plot is that we could have students think about whether they think there are outliers, or you could just go ahead and click on show outliers, and then we will see that indeed we do have some outliers. So these are the ones that have higher typical speeds. And this one is a steel roller coaster. It is called the Top Thrill Dragster. This one also is an outlier. This is called Superman the Escape. But on the other end, we have some coasters that are outliers in terms of having extremely slow top speed. So this one is called the bobsleds. And I was thinking that was going to be a wooden coaster, but it is not. It is a steel coaster. And here's another one, the Comet. So again, clicking sometimes back and forth from the table to get some more information can be really helpful. Notice again, it's showing up here. So you can very easily start looking at data and make sense of your data in terms of its measures of center, its distribution. You can do lots of other things. So we're going to give you some time in just 5 minutes or so for you to do some exploration on your own. I want to show just a couple more things. So I think someone brought this up in the chat about how maybe the type of coasters might have differences. And we watched a video, right, of a wooden coaster, and then we watched a video of a steel coaster. So we know from our own experiences or from watching those videos, riding those coasters are going to have different experiences. And it might be related to their top speed. So one way that you could look at the different types is you could pull type down and you could drop type in the middle of the graph, and then it treats it like it's a category. It is a categorical variable, but it allows you to color code where all the steel ones are and where all the wooden ones are. And in some cases, this may be really helpful to view the data this way. In other cases, people might find another representation of this useful. So another way to compare steel and wooden, I'm going to take this off the key. So you can click on this and you can remove the legend. But another way to do this is to look at two different distributions. So one of the things I love about CODAP is that we get to see our dot plot here. We also see the box plot overlaid on it, but it'll also allow us to compare distributions of different types of coasters. So for example, again, instead of overlaying type in the middle, I want to think about these two distributions because one of the things that came up was, well, are there differences? So if I drag and drop type on the vertical axis, now what I can see is and I'll make this even a little bigger. I can see these two distributions, and I can see, and I'm going to click off of it so that whatever was highlighted before wasn't highlighted. And I can see the distributions for steel and wood. One of the other things that's really nice is maybe we think there's another attribute that might have something to do with how fast roller coasters go. So one of the things that I love about CODAP is it allows you to see multiple attributes at the same time. So right now we have a quantitative attribute where we're looking at speed, and then we're looking at two distributions. We're looking at these two categories. But let's say we wanted to think about whether the design has anything to do with it as well. And so if I grab design from our case and I pull it over to the right, now what it's allowing us to do, now our data set's small, so in some of these cases we have very few coasters in each of these groups. But now it's not only letting us see steel versus wooden, but it's also letting us see the type. I'm going to add in here, though, the count, just because I do think in some of these we have very few coasters in each of these categories, and we have such a small data set in comparison to like what it means to be large. But this is large enough for many users. So you can see in this case that most of these coasters are still sit down coasters. And we looked at steel versus wooden earlier, but when you start taking these apart and looking at other types, you don't get lots of more information with this data set. So I'm going to take this off. So I'm just clicking on it and I'm removing it. Like we did earlier, you could actually put another attribute on this too, for example. So let's say you were interested in the max height. If I wanted to know something about how the max height relates to this time I'm going to drop this in the center, even though it is a quantitative attribute. And what it's going to do is it's going to put those quantities together for us and color code. So if I click on this legend, what I can see here is these are the fastest. Well, I can see that these are the coasters that are the tallest. So I see the coasters that are the tallest, but then we can see whether they're steel or wooden, and then we can see where their distribution, where their top speed falls in the distributions. And if you click on each of these categories, you can see a lot of information about coasters. So I think we are going to stop here. And we're going to let you explore a little bit. And so what we're going to do is we are going to have you individually go in and do some exploration on your own. So if you want to continue to work with this data set, come up with a question that's of interest to you. And it could be around speed again, and you could be looking at something different, or it could be a completely different question. So come up with a question of your own. And then what we're going to have you do is we've created a Padlet where we're going to have you go in and write your question and then share some type of image and maybe write a few sentences. So let us know what the question is in the post of the Padlet. Come up with some kind of conclusion, or it could just be things you noticed, or it could be things you're still wondering about. And then save some type of image from your work in CODAP to share. So let me actually go back one slide. So if I'm in, and you all might all know this, but I'm just going to show this because you need it for the next part. different ways to capture an image from your working CODAP. One way is if I click on my, let's say I wanted to share my graph window with you. If I click on this picture, I can export this as a PNG or SVG file. So I could export this, and I could either save it on my Google Drive or I could save it on my local file. And then it's going to show up like where, well, mine go to my download. So that image is going to show up where your download is. The other way to do it, I use a Mac, so I know on a PC there's another way to do a screen grab. Sometimes I just do Command Shift 4, and then I take a picture this way. So whatever works for you, but we're gonna have you do a little exploration on your own, come up with some question you're exploring, and then share your question, an image, and some thoughts that you have or questions you have using this Padlet. So if you click on the Padlet, there's already a couple of examples in here from when we've done this before. And so to post to the Padlet, there's this little plus button in the lower right-hand corner. So you would just click on the post button. Subject is where you would write your question. And then if I'm adding my image that I just took a screenshot of, it's coming from my downloads. So you would click on upload from there. You could upload from other places as well. I'm having a hard time getting to there we go. Okay. And then so once you click publish, I'm just saying, this is what I found. You guys can type something a little more eloquent. So I put in like a sentence here, my question would go here, I pull the graphic in and you click publish, and then it will appear so that other people, and we can talk about these. Yeah, so let's take about 10 minutes. Thank you so much.
Okay, so go ahead and start finishing up whatever you're working on. I see some people have been putting things in Padlet, and then in just a few seconds, we'll come together and have a couple of you share out interesting things that you found. Okay, so looking at the Padlet together, is there anybody who would feel comfortable or want to come off mute and tell us or show us what you did or what you found? If there's any, either talk about your investigative question or any like cool features that you discovered while playing around with CODAP that you think would be interesting for other people to see.
I'm happy to share
Sure.
because mine is very simple, but I'm
Okay.
thinking about, the benefit of younger learners using that. So I'm thinking about their curiosities and what they might wonder and what would be some interesting plots. So I was just curious from the like sit down and stand up and all the like ways you can be on a roller coaster, if that would, the relationship between that and speed. I thought that might be something of interest to young folks. And so my graph is there in Padlet. It took me a minute to figure that piece out. I'm sorry about that.
Let me share the
Anyways,
Padlet.
um, it's scroll down. Does the construction material? No, that's not it. It's the roller
no.
coaster with it. No, well, it's showing up on my screen. It was showing up on the left further down.
The left
Did it
hand.
not show up?
Refresh.
Oh, now
Okay,
it's-
here we go.
Oh, it is showing up because now I'm not seeing it on mine. Okay, you found it?
Everybody see it?
So anyways, it was kind of interesting because at a, like to me, if you're just like doing a simple notice, of the data, you can see the frequency of the different styles. But clearly at a certain speed, you really want to be sitting down. I'm just thinking of all the
Very
things young
true.
people might say. I think there's a lot to notice in this very simple data display.
And even talking about why might that be from a physics perspective, that you would want
Yep.
people to be sitting down. Thank you. Anybody else found anything they want to share with the group?
I'll talk about the one that Liz and I did.
And which one did you do?
Which is, sorry, how are top speed and max height related? So I think that terrifying video of the very high one inspired this investigation. And we did observe that the higher the max height, the faster the top speed appears to be. And then we layered on top the, whether it's wooden or steel. And I guess have a notice that the faster ones are steel rather than wooden.
Excellent.
And that the relationship is still true for the wooden ones and the steel ones separately.
Yes.
Can you talk more about how you know that, Tim?
Well, if I just look at the red dots, the relationship is still there. That is, the more height we have, the more speed we have. If I just look at the green dots, that's also true. So the fact that more height is associated with more speed does not depend on what it's built out of.
And just to add an aside, so if you were thinking about those young learners again, even if they're not trying to find a model that shows the relationship, they can put what, like, remember how we put the removable line in? You could put a movable line on top of that, and you could have students play with where they think the relationship might be. And remember, with CODAP, it's so easy. You could separate it by wooden and steel also, and have them play with both of them before you have them go in. Like the person that had looked at length versus drop, I'm noticing they tried to quantify, what that relationship is, but CODAP's feature of putting that removable line in, you could even put squares on the residuals and have them play to minimize the squares, helps them understand that you're trying to minimize that distance, right, when you're finding the model. And then you can put in, like in this example, you could actually find the least squares line as well. So thank you all for sharing that. I don't know if anyone, I just wanted to interject that. Sorry. I just think that's a great feature of CODAP that I wanted to share.
And I will just comment on mine, which is the one with the curvy model, the long one. And just to say, yeah, think of the things that you can do with younger students that are not interested in square root functions. And we've talked about that. But this is because I'm going to be teaching physics in a couple weeks. I was interested in figuring out, okay, for these high school seniors who have lots of experience with functions, what can CODAP do for them? And in this case, we can use a slider as a parameter for the function. And if I change the value of g, which is up in the upper right-hand corner of this thing, the square root function, which you can see at the top of that graph, square root of 2 times g times height, g will change when I drag the g slider, and that will change that function. And so I've sort of positioned it in the middle of the cloud of points, and g is 9.24 is actually not too far from the actual acceleration of gravity that you would be studying in a high school physics class. So
And I don't know, Gina, if we can allow screen sharing if Tim wants to show how to actually do that for anybody who couldn't follow along with just Tim explaining how to
I
find that.
think you're the host right now, so you should be able to allow that.
I don't know if we have time.
shall I try to share my screen?
Yeah, do you want to try and just show us how you found that?
Okay, let's see. I want to go to that thing and share this. Is it letting me? Yes, it is. And I'm going to make it smaller to help everybody, I hope. There we go. Okay, so can you now see my screen? I've now, of course, I can't see Zoom anymore. Okay, so here's the graph, and I will make it larger. And by the way, I'm going to make the points larger just for drama. And I have this function here, which I can access clicking here, square root of 2 times g times height. But g is this slider, which I made from the sliders up here. And if I drag g to be smaller, the function goes down. If I drag g to be larger, the function goes up. Oh, I can't drag it quite far enough, so I have to rescale it. It's an axis, and it can go up like that. But if I put it kind of in the middle and I say, well, what's a good value for g for this model? Here it says 9.24. And actually, in fact, it's supposed to be 9.81. But we're determining the acceleration of gravity from a bunch of roller coaster data. That's really pretty good. It's not a bad value. And it's the sort of thing that, again, people who have experience with the functions, so we're not talking about kids in 7th grade or something like that, but the 12th graders can actually handle this. And I've also had to convert, because this is in miles per hour and feet, because in physics class we're all in metric, I had to do conversions. And the conversions are something that the students should be able to do. So I will stop sharing my screen unless there are
Thank you
any
so much,
questions
Tim.
right now
Thank
about
you,
that.
Tim. That's wonderful
Okay.
to see
And I
the
don't
capabilities
need
of what it can do.
to make something that's, I mean, I'm an accredited CODAP expert, so I'm not trying to, uh, you know, I'm do that's an expert thing, and so
Yeah, I think that
don't make it.
what we've seen here is whether you're working with really young learners who are new, and I've gone in with Holly Lynn, and we started with students that were in the second week of 6th grade. So students that are, like Tim saying, have lots of experiences with functions. There's something for CODAP for everyone. I'm going to share, here's a link to you. So I had told you earlier that we have this data set where it's all the coasters. I think there are like 630 some coasters that were operating in the US. This is a way more complex data set. So feel free to use it if it's helpful. If not, um, I don't know. Are there any,
And
we have a couple minutes. Are there any questions?
uh, Ji Young Yi had to leave early, but she asked about if you could share more about how you use Padlet with CODAP in teaching.
I mean, for me, my most recent experiences have been teaching pre-service teachers or working with in-service teachers. Back in the day, I used Padlet a lot with students, but it was the way that we used it today, where I want students to share something, maybe not their whole file, um, but maybe I want them to just share something that I can have a discussion about very quickly. That's often the way I would use it. You can also, Rachel, do you have your data set open since you're sharing with the investigation? I was going to show them how to do a
Um,
shareable link real quick, but if you, I could share my screen probably too if it's easier that way.
I have it in one of these tabs. It's disappeared when I stopped sharing.
And it doesn't have to be like what you would really want to share, but I just wanted to show people
Oops.
Padlet's a way just for me to engage with students and they can engage with one another. But you can also share things using a movable link. So let's just pretend like there was something there. Do you want me to talk through it, or would you just talk through how they can share a shareable link?
Yeah, so if you go to this, these three lines, this drop-down menu in the top left, and then you can go to share and enable sharing, and it will give you a link that you can use. And so going to that link would take you to either the preview share view. There's not much there because the link I shared didn't have anything on it, but you can use that to share a link. So if I created something, and then I shared that link, anyone using this link, when they clicked on the link, would get it would open with that graph already created, that same graph. Is that what you meant, Gemma?
Yeah, I use Padlet or something else like Padlet as a way to just in the moment, if I don't want to see if I don't want everyone to share their files with one another and I just want to see what we did around something, but I was also wanting to throw the shareable link in as well. Any other questions for us? Time flew by so fast. We'll be doing some more, and I won't be me, but we'll have some others come in. It might be someone like Tim or other people do some advanced ones like in the spring. So,
More
so be on the
advanced.
lookout for some advanced CODAP. But we're happy to just take a few questions if there's any. So in our second to the last slide, Rachel and I both added our contact information. Please reach out to us. CODAP has wonderful help. So if you go to CODAP's site and you want to know how to do something, they have lots of videos or written instructions. I think they're wonderful. I work on another project called instepwithdata.org. We feature CODAP as a tool, and we have lots of how-tos related to CODAP. So that's another place where you can get information. And then in our last slide on slide 15, at the very bottom, I put a link to our esteemed curriculum materials. And so we also have a whole handout that you can use related to what we just showed you. So if you're interested in seeing more, reach out to me or you can take a look at our curriculum materials. But there's lots of great help out there for CODAP. So please let us know if there's anything we can do to support you with whatever learners you're working with.
And thank you so much for all joining us.
Have a great day, everyone. Thank you.